I'm Mike Sanders. I am a senior research associate with George Washington University in the US, and I'm here to present LAiSER. Now, if you've been to some of the other digital ed tech credentials conferences, you may have seen something like this, but a lot of this is new. And we're debuting some new data, some new visualizations here today. So hopefully it'll be exciting for you. The downfall is I have 20 minutes for a 45-minute presentation. So I'm going to talk fast, and there's going to be some stuff on the slides that I'm not going to talk directly about. So I apologize. The good news is if you want to learn more, reach out. I'm happy to do the entire presentation, happy to talk through it with you and your group. At the end of the day, this is all open source information, open source software. Things that we are talking about today are free to use. Disclaimer up here is saying that same thing and talking about the number of graduate students, the number of researchers who are already collaborating with us and trying to build this LAiSER concept up. You could be one of them too. So if you're interested in what I'm talking about today, please reach out. So when we talk about skills, when we talk about badges, when we talk about all this education and workforce information, we speak a lot of different languages. We understand what a skill is internally, but communicating that externally is often difficult. I mean, at a very basic level, I don't think we have one standard definition for what a skill is. In fact, I know we don't because I've been researching it for the last year and a half, looking for a standardized definition, and it doesn't come easily. So what we said is if we want to work in this skills universe, if we want to talk about badges, we want to talk about micro-credentials, we need to have some way of integrating these underlying skill components, defining a skill. So we started with a conceptual framework and we said, okay, what is our definition and can this definition work across different agents, different people creating it? Our definition is up there. I could have used a simpler word for operationalization because I can't pronounce it half the time. I'm awake, apparently. But we call a skill the operationalization of knowledge to perform tasks. Now, if you go into the dictionary and you read all the dictionary definitions, something like that shows up. You go into Lightcast, you go into Skills Future, you go into all these other taxonomies of skills, and they kind of get to this direction. So what we said was we need something very simple. And from this definition, we take 3 categories of data because we're data people. I'm a data scientist, in fact. So we have a category for knowledge, a category for skills, and a category for task abilities. And if you're awake and paying attention, that looks like KSA. Okay, no one shot me on stage. Bad timing. So clearly KSAs resonate in some way, shape, or form, even if we don't think that they're the most modern thing. But at the end of the day, they are part of our underlying definition of skills. Knowledge to perform tasks. So if we start with that definition, we can actually get pretty far on a data analysis framework, right? So my example here on the right is for data analytics. In fact, my wife was in a data analytics program up until a few weeks ago. Long story. So if you look at data analytics and you want to define the skill of data analytics, you take a list of knowledge outcomes from a program and say, okay, for this data analytics program, these are the knowledge outcomes you need to have. And if you look at the workforce side, who's hiring data analysts? These are the task abilities that show up over and over again. So a definition of data analytics from an education and workforce sense is 2 lists. Great, thank you. No, I'm going to keep going. I promise. So the problem with that concept is it's static, right? This is what your taxonomies across the world are using. They're thinking of a skill as a bucket. If it fits the bucket, it's that skill. We're done. It's easy. That also means that when you have something that doesn't fit in any bucket, it's not really a skill yet, right? How do you define it? Do you define it as 2 different buckets? That doesn't work. Do you define it as 15 different pieces? Also kind of cumbersome. So what we really need to do is we need to think about what a skill really is. And that helps us define it. So we added a theory of skill development. Now, this is not anything new. If you are an educational development researcher or you've done a practicum or you've even got your teaching degree, you've seen something like this. But what we've done is we've taken that same concept of what a skill is and created a developmental model on top of it. So we go, first you get the knowledge, then you synthesize the knowledge to produce a skill, and then with that skill, you perform a task. And when you can't perform a task, you need to go out and get more knowledge to synthesize and to create a new task ability. It cycles, and we hope it cycles up. It spirals up, it improves. So same example before, this is your data analytics, but say the data scientist skill is what you want. So in this case, data science is only slightly different than data analytics. And in fact, data science, in my definition here, incorporates all the elements of data analytics. So my question to you is data analytics a subset of data science? No. Thank you, Noah. These are two separate skills, but they have a lot of similarities. But if you're using a taxonomy model, data analytics is an incomplete version of data science. It's not a separate skill. This is what the fundamental problem with taxonomization of skills is. And we are all guilty of it because every country, in some way, shape, or form, has a taxonomy that's used extensively within their work. Now, I will give ESCO credit. They're working on an ontology. I'll get to that in a second. But otherwise, I think I'm pretty accurate across the world. But when we take that concept of skills development and layer it on top of our definition, we actually get a hierarchy, which again is the type of taxonomy usage that you see a lot. You have a difference between supply and demand, knowledge and tasks, and then of course our linkage of skills. And they grow over time. So you start with a single piece of knowledge. You add knowledge that's similar to create a knowledge domain, and then eventually you get a competence. We often call these degrees. So this is a diploma here at competence to some extent. On the other side, you have tasks and task domains and jobs. Everyone wants a job, right? So when you get hired for a job, you have to have several task domains to be able to complete what you're working on, and you need to be able to complete each task. And the skills are linkage in the middle. So that credential there is a proof of skills. You'll notice that competence and credential are separated here. They have different concepts, but similar meanings. Okay? This is our hierarchy. And again, it's incomplete because you have that overlap. You have that linkage that's unclear in a bucketed type system. So let's talk ontologies. I know ontologies are a little bit more complex than we normally utilize, but the concept's pretty simple. We are linking these skills together, and we're actually using the linkage information, what is common amongst them, to define the skills in this case, or define the information. So it's not necessarily a skill exists. It's that all these pieces, this knowledge, this task ability, overlaps in such a way that it represents where that skill should be. So think of it as we don't observe the skill, we observe the skill components that define the skill, and then we put a label on that skill. Again, this would be a cool stopping point, and I'm like, we've revolutionized what we're doing here. But still, we're not quite there because this isn't operable yet. This is a conceptual framework, right? So let's talk a little bit about how we get there. So if we're talking about building an ontology and we want to do it quickly, efficiently, especially with AI making things so quick, in theory, I don't agree. We can take what we already know in taxonomies and build them together to actually build an ontology. So we can say, if all human skills need to be represented, we can take the incomplete taxonomies, the ones that don't really define skills accurately, as I've been arguing, and build on top of them and create a linkage. Now, I think you've seen this concept in other talking points in other presentations. In fact, I saw it yesterday and was very excited. But what we've done is we've taken 14 different taxonomies so far and built this, and we keep adding. We are creating a tool, and still validating, so I haven't released it yet, that will add any taxonomy to this ontology, essentially create the relationship model. And so far, we have around 30,000 different skill definitions incorporated into this ontology. So I'll pause here and make a very bold claim. This ontology should never be finished. What it ends up becoming is a list of lists, a linkage option. So in 10 years, when the newest, shiniest taxonomy ontology is out, we can still add. All right, so this is a living document. And now we get to LAiSER. So I've just told you about our conceptual framework. I've told you about building an ontology to try and understand the world, but I haven't told you about what we're actually doing, except that it's open source and free to use, so on and so forth. But what LAiSER is it's effectively a opportunity for us to take all these different sets of data that are sitting out here in all these different projects we've heard about this week, and all these different concepts that are out here, all these different university credentials that are out here, and put them in a similar language, in a common field of reference, and be able to say, okay, I know this, and here's how they work together. That's what LAiSER does. And again, I could stop my presentation here and say, you've learned something, but I want to show you some pretty graphics and tell you about what I'm actually doing. So there's 4 key tasks to LAiSER. We identify, we extract, we correlate, and then we map. Pretty straightforward. Lot of data science, a lot of coding to get there. But that identification of skills is what we just did. We defined skills and we created a framework in which we can fill. The rest of the tasks are relatively simple data science things. We have to extract skills from human readable information. We have to correlate this information together to talk about where those relationships are, and then we want to produce some way of understanding how they're related. I'm going to go a little bit quick through these just to save some time. So our identification is essentially saying in human readable documents, the skills, task abilities, and knowledge are represented in a fairly standardized way. So a task or a knowledge ability, task ability or knowledge, maybe it is too early for me. Those are often represented by nouns. They're saying, I can do this, I know this, these are things that exist, these are tangible, and they're also easier to find because of that. Whereas skills are generally verbs. They're things that connect. They're saying, I know this, so I can do that. I know this, so I can do this other thing. So when we talk about skills in language, there's verbs and considerable associated text that often defines the skills. So we have a framework here that helps us identify this. The next step is extraction and collocation. So extraction is essentially using AI to pull out this information from the ontological viewpoint. Essentially, we built this ontology to teach the AI what a skill really is and what to be looking for in knowledge and task abilities. Pull all that information out, and then we look at it from a global perspective. So say 60 million plus job postings, 11 million syllabi, almost a million textbooks. We can go through and process this and actually create a huge data set and see where these skills, these knowledge, these task abilities co-occur. And say, if you are learning this, you tend to be able to do that. If you are in this class across all these universities, they tend to have these learning outcomes. So all these repeated observations of all this information gets us to a machine learning model. Essentially, it gives us the information on those relationships. That correlation is also informed by other data. So we're not just talking about within a document, we're talking about within a program. So that's a linkage layer. So if we talk about the actual data we work with, we have currently 15 different layers that we're analyzing, with more being added as we improve our data extraction process. To be able to say, not only here's the collocation, but here's the other descriptors of all this data. So we can actually build that relationship model not just on observation, but on real empirical data on top of it. And then finally, we map this. The mapping is the fun part. It's the great visuals. I promise there's great visuals here in a second. But when we build a map, we also build the context. So context is the idea that I, from DC, have a different world of jobs and education than you here in Paris, or someone in Milan, or someone in South Africa. Those contexts are different. So we don't want to assume that all of the skills and how they relate are the same across these countries. Now we have a lower level layer that says globally skills exist in this concept. That was the ontology we started with. But locally, we don't. So we build local context. So let's talk about some applications. I know I'm running out of time, and I will move quickly through this, and I'm happy to talk more later. Here's some of the projects and concepts that we've been developing to do this work. We want to use it for workforce hiring. So if you want to hire someone off of LinkedIn, or you want to deal with someone who has submitted an application, this type of process is useful. Credit transfer, skills resume, accreditation, so on and so forth. There's a list here, and there's quite a few more that didn't make the page. I ran out of space, frankly. Using skills to translate human readable documents is an opportunity to deal with a lot of these inefficiencies. And a lot of the projects that we've heard about today fall into one of these categories. What we're talking about doing is breaking down those categories and trying to link all this data together using skills. So let's see it. So this one is a mocked up version. I will admit that the AI didn't do all the extraction. We cleaned it by hand. But what's on the screen here in red is job description information, skills pulled from a job description. Green is work experience of a individual test case, and blue is the education of this individual. So if you want to hire, you can take that LAiSER process, extract skills, put the skills on a map, and this is what you get in 3 dimensions. That 3-dimensional representation gives you the ability to add a layer of logic to say, well, how good is this candidate in this hiring example? You can do a centroid distance process, and we did. And this theoretical candidate for this theoretical job had an 85.3% alignment. That's just a layer of math. That's not hard to do.
Explain it for people who aren't data.
The center of clusters for skills, we measure the distance between the nearest centers. So essentially that's saying the employee and, well, potential employee and the employer have 2 sets of clusters. So the distance between the closest clusters representing this skill domain, that's how far apart they are. And because of how this actual map is set up, it's talking about information of tasks and levels and knowledge relationships. That because there's 15 different dimensions being represented in 3, it's a little bit more complex than that, but the simple explanation. So that alignment is one of the logic models you can use. There's many others. So we talked about individual distances, skill to skill distances. What's your closest skill to mine? You know, those types of solutions also work. But we're trying to be the folks who produce the map, not do the logic. So that logic's going to be on whoever's using this, you know, final product. So this is the brand new slide that no one's seen. This was pulled yesterday. So this is 3 different jobs that we pulled out of Google Jobs, I think it is now. But basically we said, what are the 3 most recent job postings? We pulled out from those job postings and found the nearest skill tag to each of the skills we extracted, created the correlation coefficient, which is actually cosine similarity for the data scientists here, and said, okay, here's how good this skill is linked to our taxonomy value. And then we mapped it for DC region. So this is an actual map. It's task ability, knowledge, and level information. The size of the dots represent the correlation coefficient here. So these 3 jobs, here's how they overlap. This is all raw. We haven't done any cleaning to this. But that was a quick map done in under a second. We can do that over and over and over with as many documents as you need. Now, the mapping itself will improve as we ingest more data. But as a quick example, that was really fast and ready to go. Here's a bigger example. This is actually from a partner, Open Syllabus, that you may be familiar with or not. This is a knowledge graph. So this is 2 dimensions, 3, because we don't have the levels built into this. But these are the relationships between subject knowledge outcomes within subjects for colleges across the world. So you can zoom in, and this link is pretty easy to find. It's opensyllabus.org. But if you look at all of the different names up here, even if they're hard to see in the projector, this will show you how all these knowledge clusters. And we do this for millions of job postings, and millions of syllabi to create those maps. Okay. So I will very quickly state some of the current projects we're working on, and you could be on this list too. My absolute favorite one is mapping skills in associate degree level humanities courses. NOVA, Northern Virginia Community College, has been very interested in their very large catalog of humanities classes that people have stopped taking because they aren't learning new skills. So we're actually going through and mapping all of NOVA's humanities courses to skills from the DC region. And that work is expected to be done in May with a new report, essentially showing, hey, humanities courses probably have some skills value. These other projects all have their own ideas and all have their own end goals, but the commonality amongst them is using our extraction tool and associations to be able to get to the endpoint. Now, the last comment I'll make before I get too far out, if you're talking about badges and you're talking about international badges, you may have noticed that a lot of this descriptor didn't really go into US specific information. Yes, I'm using a US data set for jobs and international data set for to some extent, knowledge. It doesn't have to be that way. In fact, we can be multilingual to start with because the AI we use is multilingual. We can actually do things like validate badges or create badges or identify where a badge might be through clustering in your coursework. We can do things like validate skills resumes. Essentially, if you need to go in and apply for a job, you can upload your resume, pull out the skills you have, and anything that is already validated in terms of credential can be identified, and then you can add validation for skills that may not be already valid. Lots of different project opportunities, and we're looking for people to work with. We're looking for ideas, especially international. We were talking with Scotland. Hi. We will talk with other countries. I was in Estonia a few weeks ago giving this presentation. They gave me 5 minutes. At the end of the day, we're building a tool. It's open source. We want to work with you to integrate these concepts, even if it's not our tool directly, into what you're working on, because we believe that skills are a common language across everything we're doing. Everyone in this room uses skills, and we think that it's an opportunity. So T3, I know you're in here. I know you're on that same page with us. I know there's European Commission, there's OECD, ESCO, all these people working in this direction. And we just want to help you take this American-based product and integrate it where you need it. I would be remiss if I didn't mention my research partners here. NLX in particular, I've missed previously. NLX is a big data provider for us. This is our team, including Tom Weko, who's up front. And if you have questions en français, Tom will help. Translator helps too. And I'll leave this on the screen. This is a link to our website. And I will note that we did launch the version 0.1 of the extraction tool 2 weeks ago. And that is also available on GitHub. And I will send you a direct link if you like later. Thank you very much.
So thank you for reminding us that skill is a verb. And you might say that to ESCO because ESCO is a big mess, okay?
Yeah.
They've not understood that. So if they could learn that from you, that would be great.
I learned that from them, actually.
One question, maybe?
Questions?
Before the break? Question? Or you can speak around the cafe.
Could you go back to the slide where you had, it was like red, green, and blue, not that, yes, that one there. Okay. In my experience, the job description is done by HR, who have no clue really about what's going on. They copy and paste. The green, they do. HR copy and paste. Well, that's what happens. The green bit, I'm not entirely sure about how you're pulling out the skills and work experience. And then the blue, like the way that professors describe what happens in terms of skills within courses is very different to how employers do it. So I'm still unclear, and maybe because I haven't had enough sleep, how they are all talking about the same thing.
And this is a 20-minute presentation of a 45-minute.
Right, okay, sorry, I'll talk to you outside. It's
the
fine.
very short answer to your question is these are inferential. So we did that correlation. So we're talking about not just one job. We're talking about 20,000 versions of a similar job. So these are the most common skills associated there. And because we're doing deduplication and we're doing outlier analysis and the types of things that go, well, we extracted all these skills, but these are poor matches and we don't see them occur anywhere else, they're dropped. So what you're getting is the cleaned version. So when I show you this one, you see how many more spots are on here and how many tiny, tiny dots are on here? That's pre-cleaning. We haven't done anything.
If you've applied for a job, let's say you're applying for a job here, you're getting mapped against this. Is that right? Okay.
And essentially what that job in red is the standard job classification information, as well as the items they're asked for in the job itself. So it gives you that breadth, and that distance is effectively created by saying, here's your idealized plus your validated, compared to the job request versus expected. So it's a little more complete, but it's not perfect. And the more iterations we do, the closer we get.
Thank you very much. It's time for the coffee now, so thanks a lot.
Leave that.